Hello everyone, welcome to the channel Top Gate. In this video, we'll discuss one more concept, that is the concept of Moore machine. So if you go back to a few of my previous lectures where I explained about the finite automata, there I told you that the finite automata is of two types. One is finite automata without output and the other one is finite automata with output. In the first category, that is the finite automata without output, we have two machines, namely the NFA and the DFA, that we have already discussed in the previous lectures. And in the second category, that is the finite automata with output, we again have two machines, namely the Moore and the Mealy machine. Okay? This video is specifically for the Moore machine, but before telling you what a Moore machine is, I'll first tell you some general points about the Moore and the Mealy machine, that is the finite automata with output. So the first point says that both of these machines, the Moore and the Mealy machine, they are the special cases of a DFA. Now we know that what a DFA is. DFA is a deterministic finite automata. It is a complete system in itself. So in a DFA, we know that every state must have exactly one outgoing path for every input alphabet. Alternatively, you can say that if you apply any input alphabet to any state, you will move on to a single state only. Clear? So both of these machines, the Moore and the Mealy, they work like a DFA only. They are a special case of DFA. There are some limitations, I'll tell you later on, but these are a kind of a DFA only. Second point says they act as language producers and not as acceptors. Now what does that mean? The NFA and the DFA, they both act as a language acceptors. That is, we check whether a particular string or a language is accepted by the NFA or the DFA. Now this acceptance or rejection is finalized on the basis of reachability to the final state. That is, we start from some initial state, we hop around the states, and if we are able to reach on to some of the final state, then we say that the string or the language is accepted by the NFA or the DFA. But this is not the case with the Moore and the Mealy machine. They are not the acceptors, in fact they are the producers. That means they produce the language, they produce the string, but they never accept the string. Now what do you mean by the production of the string? In this one, the output is associated with the state and the output can be associated with the state as well as with the current input. Clear? So to produce a particular string, we don't have to go to any of the final states. In fact, upon reaching to any of the states, the output is getting generated. Now how it works, I'll tell you later on. Clear? So we know that the Moore and the Mealy machine, they act as language producers and not as acceptors. Third point says that there is no final state. Obviously, if they are not accepting anything, if they are not rejecting anything, that means there will be no final state. Final state is not required in this one. Clear? Fourth point says that there will be no dead state. Now, we know that the dead state is associated with the final state only. In the previous few lectures, we have seen that a dead state is a state that if we reach on to that state, there will be no means to reach on to the final state. Now, since there is no final state in this one, therefore, there is also no concept of dead state in Moore and the Mealy machines. And the last point says that the power of the Moore machine and the Mealy machine is exactly the same. That is, any work which can be done from the Moore machine can also be done with the help of the Mealy machine also. Clear? So these are some general points about the Moore and the Mealy machine, or the second category of the finite automata, that is with output. Clear? So now we'll move on to our ultimate target, that is the concept of Moore machine. Whenever we define any machine in theory of computation, we define it in the form of tuples. Like we had certain tuples in the case of NFA and the DFA. In the case of NFA and the DFA, we had 5 tuples. But in the case of the Moore machine, we have 6 tuples. So first of all, I'll explain to you what are these 6 tuples, and then I'll tell you what exactly a Moore machine looks like, what is the transition table of a Moore machine, and how this transition table can be converted to a transition diagram, and then I'll discuss one example. Okay, so in Moore machine, we have 6 tuples, namely Q, sigma, delta, full delta, Q naught, and lambda. First one is Q, that is finite set of states. It was also there in the case of NFA and the DFA. Then the second one is sigma, that is the input alphabet. Again, it was there in the NFA and the DFA. Third one is a transition function. Since I told you that this Moore machine works like a DFA, so it is same as the DFA only. That is, if you apply any input alphabet to any state, you will move on to a single state only. Clear? And then we have a full delta. Full delta is the output alphabet. Now, why we are having a output alphabet in this one? Since I told you that this Moore machine acts as a language producer, that means if we visit any particular state, on that state only some output is produced. Now that output is denoted by this full delta symbol. And the next one we have is Q naught. Q naught is the initial state as we had in the NFA and the DFA. Then the last one we have is the lambda. This one is the most important thing. It is the output function. Now this output function is the symbol because of which a machine becomes either a Moore machine or a Mealy machine. So for the case of Moore machine, this lambda says that Q gives full delta. That means on any state the output will be produced. What is the full delta? Full delta is the output alphabet. That means with every state one output will be associated. Clear? So this is the description of the 6 tuples of the Moore machine. Now let's see here. This is the transition table for the Moore machine, and let's see how do we convert this transition table into the transition diagram of the Moore machine. So first of all, I will just draw it like the DFA only, and then we'll incorporate some changes, and then we'll call this as a Moore machine. So we have 4 states in this one, namely we have Q naught, and then we have Q1, and then we have Q2, and then we have Q3. Clear? So I told you that there is no final state, so I'm not marking any of the final state. This one can be considered as the initial state. So Q naught is my initial state. Okay, so from Q naught with 0, I'm moving on to Q3. So from Q naught with 0, I'm moving on to state Q3. Clear? And from Q naught with 1, I'm moving on to state Q1. So 1. Clear? Now Q1 with 0, it is Q1 only. That means it is a self loop. And from Q1 with 1, it is Q2. That means this is 1. Now come to Q2. From Q2 with 0, it is self loop. That is 0. And then from Q2 with 1, I'm moving on to state Q3. Clear? Now come to Q3. On Q3 with 0, it is a self loop. So I'm just adding a self loop here. And then from Q3 to Q0 with 1. So to Q0 with 1. Clear? Now this is just like the DFA. Now you see here, the last column says that it is the output. So this means that 0 is associated with state Q0. 1 is associated with state Q1. 0 is associated with state Q2, and so on. Clear? So how do we mark this? We mark it like just like this, like we have the state Q0. So in Q0, I'll just put a comma here and then add 0 here. This means 0 output is associated with the state Q0. Okay? And similarly with Q1, it is 1, and with Q2, it is 0, and with Q3, it is 0. So this is your required transition diagram for this Moore machine. Clear? So now let's try to understand with the help of some example that how this Moore machine can be used to generate some particular string. Okay, so suppose the input alphabet, the input string that we have is say 0, 1, 1, 1. Clear? So if we have 0, 1, 1, 1. Now if we apply this 0, 1, 1, 1 input string, then what is the output generated for this particular Moore machine? Now let's see. So the first state, the initial state in this one is Q naught. Okay, so as soon as we reach on the state Q naught, you see that 0 is associated with the state Q naught. So straight away, without applying an input alphabet, I have seen one output. What is the output? The output is 0 here. Clear? Understood? Okay. Now, my first input alphabet is 0. Clear? So I'll apply 0 here. So I'll apply 0 input alphabet. Now, on applying 0 on Q naught, on applying 0 on Q naught, I'm moving on to state Q3. So therefore, I'll write Q3 here. Now, as soon as I reach on to state Q3, I see that with Q3, 0 output is associated. So On reaching state Q3, I have got one more output as 0. Clear? Now, my second input alphabet is 1. So here I'll apply 1 input alphabet. Now applying 1 on Q3. So on Q3, 1 applied, I'm moving on to state Q0. So I'll write Q0 here. Now as soon as I reach on to state Q0, I know that with Q0, 0 is associated. So I have got one more output alphabet, that is 0. Clear? Now my cursor moves on to the next one, the next input alphabet, that is 1. So on Q0, I will apply input alphabet 1. So on Q0, when I apply 1, I'll move on to the state Q1. Clear? So on reaching on to state Q1, I know that with Q1, 1 output is associated. So straight away, I'll give 1 as the output here. Now the last input alphabet is 1 now, and I'll apply 1 on Q1. So on Q1, 1 applied, I'll move on to the state Q2, and at state Q2, I know that a 0 output is associated. So I'll write 0 here. Okay, so on applying input string as 0 tuple 1, the output that I'm getting is 0 1 1 1. I'm getting the output as 0 0 0 1 0. Clear? Now if you see this one closely, if you analyze it, you see that in the input we have 1 2 3 4 characters. But if you see the output, in the output we have 1 2 3 4 5 characters. That means if the input is of n characters, the output generated will be n plus 1 characters for the case of the Moore machine. Now this one is very important. Clear? Now why we are getting 1 character more than the input in the output? That is because without applying any input alphabet onto the initial state, I am seeing 1 output. You see here at Q0, I haven't applied any input alphabet yet, and I have received 1 output alphabet. So that's why I'm getting 1 character more than the input in the output. Clear? So this is your Moore machine. Thank you so much.